Have you ever pondered how a sudden burst of energy from the sun could impact life on Earth? Welcome to our exploration of solar flares, a fascinating phenomenon that occurs on our closest star. Solar flares are sudden flashes of increased brightness that are usually observed near the sun's surface, often in close proximity to a group of sunspots. These aren't merely visual spectacles, though. They're also potent eruptions of energy, releasing vast amounts of light, heat and particles into the cosmos. Imagine the sheer power necessary to cause such a spectacle, the energy equivalent to millions of hydrogen bombs exploding at the same time. This energy is cast into space, traveling across the 93 million miles that separate us from the sun. The question then arises, what happens when this energy reaches our home, the Earth? As it turns out, these solar flares can have a significant impact on our planet. Stay tuned as we delve deeper into this fascinating topic. To understand the effects of solar flares, we must first delve into how they occur. Imagine the sun as a big ball of gas with a magnetic field. This magnetic field is constantly in motion due to the sun's rotation, and this movement leads to the accumulation of magnetic energy in the sun's atmosphere, known as the solar corona. Now, every so often, this energy reaches a tipping point. It becomes too intense to be contained any longer, and it's suddenly released in the form of a solar flare. This is a powerful burst of radiation that can be seen as a bright spot on the sun's surface. But not all solar flares are created equal. They're actually classified into 3 types based on their strength: X-class, M-class and C-class. X-class flares are the real heavyweights here. They're the most powerful and can cause major disruptions on Earth, such as power grid failures or satellite damage. M-class flares are the middleweights. They can cause brief radio blackouts at the poles and minor radiation storms that might endanger astronauts. And then we have C-class flares, the lightweights. These are small, with few noticeable consequences on Earth. The classification doesn't just stop at the type, it also includes a number. This number provides more information about its strength. For instance, an X2 flare is twice as powerful as an X1 flare, and so on. It's important to note that while these flares are indeed powerful, they can't physically harm humans on Earth's surface. Our atmosphere does an excellent job of protecting us from the harmful radiation. However, they can affect our technology, and in today's digital age, that's a significant consideration. These spectacular solar events can have far-reaching effects that extend all the way to our planet. But understanding the science behind them is the first step to mitigating their potential impacts. And as we continue to study and learn more about our sun, we are better equipped to prepare for and respond to these solar events. Ever wonder why we don't feel the heat of these solar flares here on Earth? It's all thanks to our planet's inbuilt protective shield, the magnetosphere. This invisible magnetic field envelops our world, acting like a cosmic umbrella that deflects the majority of the sun's fiery tantrums. Solar flares are bursts of radiation that explode from the sun's surface. These flares carry with them a cocktail of high-energy particles, which, if they were to reach us directly, could be potentially harmful. But fear not, our magnetosphere steps in to save the day. This protective field absorbs and deflects these particles, shunting them towards the Earth's magnetic poles. It's this interplay of solar particles and the Earth's magnetic field that creates the beautiful ethereal light shows we know as the aurora borealis and aurora australis. However, there's a twist in this cosmic tale. Intense solar flares can distort the Earth's magnetic field, causing what we call geomagnetic storms. These storms can have a range of effects, from creating dazzling auroras that can be seen far beyond their usual locations, to causing disruptions in our satellite and communication systems. But don't worry, these effects are usually temporary, and our scientists are always monitoring solar activity to predict and mitigate these issues. In the grand scheme of things, the Earth's magnetosphere does a stellar job at keeping us safe. So we are shielded from most of the harmful effects, but not all. Solar flares, while fascinating, can cause some significant disruptions here on Earth. These fiery eruptions on the sun's surface don't just stay in our solar neighborhood. No, they have a way of making their presence felt right here on our home turf. Let's delve into how these solar tantrums can play havoc with our modern lives. Imagine this. You're in the middle of a crucial business call and suddenly the line goes dead. Or maybe you're navigating through an unfamiliar city and your GPS starts acting up. These are not just random glitches. They could very well be the handiwork of solar flares. You see, when a solar flare erupts, it ejects a burst of electromagnetic radiation into space. And when this radiation reaches Earth, it can interfere with radio communications, causing disruptions in everything from your mobile phone service to aviation communications. But it's not just our conversations that are at stake. Solar flares can also play mischief with our power grids. The electromagnetic radiation can induce currents in power lines, causing voltage fluctuations that can, in extreme cases, lead to widespread power outages. And let's not forget about our satellites. These invaluable tools orbiting our planet are particularly vulnerable to solar flares. The intense radiation can damage their electronic systems, disrupting services ranging from weather forecasting to television broadcasts. But it's not all doom and gloom. Solar flares have a brighter side too, quite literally. When the charged particles from a solar flare collide with atoms and molecules in our atmosphere, they can create a breathtaking light show known as the auroras. These beautiful displays, often seen near the poles, are enhanced by solar flares, adding a touch of celestial magic to our night sky. So while solar flares can create some challenges, they also contribute to one of nature's most stunning spectacles. Solar flares, these magnificent solar phenomena, serve as a reminder of our sun's power. We've traversed through the science behind these fiery spectacles, their interaction with Earth's magnetosphere, and the tangible impact they have on our lives. It's clear that our understanding of these celestial fireworks is not merely academic, but critical. They remind us of our place in the cosmos and our relationship with the sun. Next time you gaze up at the sun, remember the incredible energy it holds and the subtle ways it shapes life on our planet.